This is 3-7. The good news is this stuff is largely algebra, so you've seen it before. But we have to review it a little bit for what we're going to see coming up. So today's kind of a review lesson. Equations of lines in the coordinate plane. All right, so first thing, can you tell me what slope is? Or anything about it?
Don't they give you the slope in an equation?
Often there's a slope in different forms of equations, yes.
It's like the y-intercept? No.
There's a slope-intercept form where there's a y-intercept and there's a slope.
But the slope is where the line meets the x?
It's not where the line meets the x. It's kind of the tilt of the line, right? So this could be the slope of the line, or this could be the slope. So it's kind of the tilt of the line that we're working with. But the way we often refer to it is it's rise over run. Yeah. The slope formula to figure out rise over run is this. Does this look familiar to you? Y2 over y1, y2 minus y1 over x2 minus x1. Do you remember that at all? So that's the slope formula, which is what we're going to use in this first example here. So let's say, I need to get a picture. Okay, so we have this graph, and we're going to draw a line in it. So let's say I give you the point -1, 2. -1, 2. And I give you the point 4, -2. 1, 2, 3, 4, 1, 2. Okay, and then that creates, oh, I missed. My lines are not straight on here. You need a straight edge?
Well, it's not like my binder out.
Okay, so if that's my line, what I would do if I were you, in order to find the slope, which is what we're going to do, okay, the letter that represents slope, by the way, is an M. So when you see M, they're talking about slope, okay? Slope is M. So to find our slope, we have to figure out what is our x1, what is our y1, what is our x2, what is our y2, okay? So if we call this x1, y1, does that show up okay for you? It's not terrible. And this one x2 and y2, then that just helps us to plug it into the formula. So what you're going to do is y2, so -2, minus y1, which is 2, over x2, which is 4, minus x1, which is -1. And notice it's minus a -1. Don't just go -1 because it's a -1. We have to subtract. So -2 minus 2, that's a -4. 4 minus a -1 is plus a +1, so that's 5. That means the slope of that line is a -4 over 5. Okay, so y2 minus y1 over x2 minus x1. So try it with these points. Let's... Cause whatever point it is, like this is the point -1, 2, right? That point. So I just called that x1, y1. You could call that x2, y2, and this other one x1, y1, but you just have to keep your 1's together and your 2's together. So it doesn't matter which one is which. It just matters that your x1 has the y1 with it and your x2 has the y2 with it, okay? Okay, so let's say we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. 5, 7 is up here. Yikes. And then 2, 3. 1, 2, 1, 2, 3. That's right here. Okay, so that would be this line. I'm gonna make it blue just so we're seeing there's a difference. Okay, so find the slope of that line for me. And then I'll work it out for you in just a second. All right, what'd you get? 4 over 3. Did you get it? Yeah, 4 over 3. Okay, so if you do, this is x1, y1, and this is x2, y2. We're going to do y2 minus y1, so 7 minus 3. x2 minus x1, 5 minus 2, so 4 over 3. But let me show you how it doesn't matter if you flip them. So if I would go 3 minus 7 over 2 minus 5 and go the other way with it instead, I'd get negative 4 over negative 3. What's a negative divided by a negative? A positive, right? So regardless of which one you use as your 1s and which ones you use as your 2s, you'll get the same thing, okay? So take your pick, whatever feels more comfortable. Okay, so when we're talking slopes, I'm just gonna draw you 4 quick pictures just so you can tell the difference between the different slopes that are options. Totally up to you. I'm going to tell you what a positive, a negative, a 0, and an undefined look like. So it's probably a good idea if you don't know what those slopes already look like. So this first one looks like this. Second one looks like this. Third one and fourth one. Okay, so your different slopes just depend on what direction they're going. So here you have one that's on its way up, you have one that's on its way down, you have one that's horizontal, and you have one that's vertical, okay? Any guesses what will be true of that first slope? It's positive, right? If a slope is on its way up, that's a positive slope. So this would be a positive slope. Okay, so what do you suppose is true of the second one then? It's on its way down, it's a negative slope. Okay, and then these two are the ones that I feel like get mixed up the most. One of them is 0 and one of them is undefined. Do you know which one is which? 0 is the third one, actually. So a horizontal line has a slope of 0. Here's how I often tell people to remember it. This is a horizontal line, right? And the word horizontal has essentially a 0 as its second letter, right? O and 0 look a lot alike. So I always tell people, try to remember it that way. Horizontal has a slope of 0, and then vertical has an undefined slope. Okay, and if you think about the word vertical, a V and a U, those are very similar letters, so maybe that will help you identify it. So positive, negative, 0, and undefined, those are some of the slopes that you're going to see on a regular basis. Any questions on what those are? Okay, then I have 2 forms of equations that we're going to be working with. The first one is slope-intercept form. Anyone remember what slope-intercept form looks like? Y equals, remember? y equals mx plus b. So in this form, the m is always your slope of your line. And then the b is what you were talking about earlier, Daniel, the y-intercept. Sorry, I kind of ran out of room there. Can you tell that's y-intercept? So y equals mx plus b, we're going to do a lot with a slope and a y-intercept. But then there's also point slope form. And this one you'll have a point and a slope, conveniently named. This one is y minus y1 equals m times x minus x1. Okay, so point slope and slope intercept. In this one, this is your y coordinate and your x coordinate. And then you still have that slope in the middle. Okay, so that's kind of your setups for the forms. What we're going to do is we're going to graph in those forms. So I'm going to show you kind of how they play out a little bit. And then I got a couple more examples for you. Okay, so if I tell you to graph y equals 2/3 x plus 1, okay? This is slope-intercept form. So you have a slope, right? Here's our slope. And you have a y-intercept. That's the b. Do you know when you graph this, which one of those you plot first? The slope or the intercept? It's the y-intercept. Because from your y-intercept, then you can move the amount that the slope needs to move. So what you're going to do is you're going to start here. Okay, so we have a positive 1 as our y-intercept. Which one's our y-axis? The vertical or the horizontal? The vertical. This is our y-axis. This is our x-axis. So if we're looking for a y-intercept, that's where does this 1 hit my y. So what you're going to do is you're going to go up 1 on the y-axis, and that point right there is then your y-intercept, okay? From there, now you can move your slope. So your slope is 2/3. Do you remember, do you go up and down first or left and right first? Up and down. It's rise over run, right? So you're going to go up 2 because it's positive. So up 2, and then to the right 3. 1, 2, 3 to the right. So we went up 2, 3 to the right, and that gets us this point. So when we graph this equation, it looks like that. Does that make sense? Coming back to you? Okay. So what if I said graph y equals, let's do this one in a different color. Y equals negative 1/4 x minus 2. What do I plot first? The negative 2. And so are we going up or down on our y-axis? It's a negative 2. So you're going to go down. So 1, 2. You can use the same graph. So you go down 2. Okay, that takes care of that negative 2 portion. Now our slope is negative 1/4. So you got to think, where do I move for a negative 1/4? Well, it's negative, and it's rise over run, right? So it's up and down first, and then left and right. So we're going to go down, because it's negative, 1 unit. So you're going to go down 1, but then you always, even though it's a negative number, our denominator is technically positive then. So you're still going to go to the right. So you'll always go to the right. You just have to decide, do I go up first or down first? Okay, so we're going to go 4 to the right. 1, 2, 3, 4. That would be right there. And then you draw that line in. So this equation graphed would be this line. Okay, so down 2 and then a slope of negative 1/4. Good on that? Okay. The second one is the one that usually tends to give people a little more trouble. That's point slope form. I gotta move my work one to a different place. Where'd it go? There it is. Okay, so for this one, now you're gonna get a different form. So they tell you to graph. Why are we doing that? This equation, y minus 3 equals negative 2 times x plus 3, okay? So here's where you have to really pay attention to your numbers. You have a point and you have a slope. So the point is made up of this number here and this number here. But here's the thing. Which one's gonna be our x value? The one on the left or the one on the right? The one on the right, okay? So it's backwards of what you would think because the y is actually first here and the x is second, but we need an x and a y in our point, okay? The other thing that's weird about these is it's the opposite of what it looks like because the equation, remember the equation looked like this, y minus y1 equals m times x minus x1. So if it says x plus 3, that's because I did x minus a negative 3, right? Because it's subtraction in the formula. So negative 3 is actually my x value. And then y minus this is my y value. So my y value, even though it looks negative in the equation, is actually positive. Okay, so you have to flip them this way, and you have to make what looks negative positive and what looks positive negative. Does that make sense? So you're doing two things to it. Okay, so we get this point. Negative 3, 3 would be 1, 2, 3, 1, 2, 3. Okay, so that's our point. And then we have a slope of negative 2. Do you know where you move for a slope of negative 2? If you think of it as a fraction, negative 2 is negative 2 over what? 1. Okay, so you need to move negative 2 over 1. So you're going to go from here, you're going to go down 2, and then to the right 1, which is going to get you this point. So your line is going to look like this. Okay, so first do the point, then do your slope. Okay, how about this one? Just use the same graph again, that's fine. If I do y minus 2 equals negative 1/3 times x minus 4. Okay, my point, what's my x value for my point? Your x value is a 4, right? It looks like a negative 4, so it's actually a positive 4. What's your y value? What? Positive 2, right? So you had your 4 for your x, your 2 for your y. It looks negative, so it's actually the opposite, and it's positive. So 4, 2 is going to be your point. So you're going to plot that first. 1, 2, 3, 4, 1, 2. Okay, and then what's your slope? Negative 1/3, right? So if you're doing a negative 1/3, you're going down 1/3. So you would get this point right here. You always move to the right 3, okay? So then if we draw that in, it'll look like this. One way to check is a negative slope is on its way down, right? Well, this was a negative slope, and it's definitely on its way down. This was a negative slope, and it's definitely on its way down. So then you know you're at least in the right mode with your slopes, okay? Questions on that? Okay, 2 more examples, and these ones are quick. No more graphing. What are you stuck on? How I plotted this? So I plotted 4, 2, right? So 1, 2, 3, 4, 1, 2 got me this point here. And then from that point, you do a negative 1/3. So from there, you're going to go down 1 and then to the right 3. Okay. You're wearing contacts? You're just getting all kinds of your stuff back. Glasses, contacts. Good job. But you don't feel like contacts work as well?
No, they work well. I'm blind, like you with contacts on.
Yeah. You need a new prescription. I gotta take my kiddo to the eye doctor today. Okay, example 3. You're gonna write the equation of a line now. If I tell you you have a slope of 3 and a y-intercept of -5, okay, and I tell you to write the equation of a line. First of all, you have to ask yourself, what do I have? I have a slope and a y-intercept. So which form uses a slope and a y-intercept? Slope-intercept, right? So it's going to be this form of the equation. Y equals mx plus b. Okay? So now we got to figure out what goes where. What replaces the m? The 3, right? That's your slope. So 3 is going to go here. So it's going to be y equals 3x. And then your b, you got to be a little bit careful with here, plus, what's b?
Oh, that's a negative.
It's a -5, right? So really, it's 3b plus a -5, or an easier way to write it is just 3x minus 5. That's the same as plus a negative. So I would write the equation like that.
I didn't see the negative, that's why I said positive.
It's all good. Okay, so that's slope-intercept. They give you the slope, they give you the intercept, you just plop it in the form. Okay? If instead they do the equation of a line through the point -1, 5 with a slope of 2. Okay? This one's a little more difficult because now you have a point and a slope, so you have to put it into that point slope form, right? That's y minus y1 equals m times x minus your x1 value. So you just need to identify what's your x1, what's your y1. So the -1, that would be your x1. The 5 would be your y1. The slope is your m. So you're going to take those values and you're going to plug them into the formula. So what would that look like? Y what? Y minus 5 equals, what's m? 2. And then x what?
Plus 1.
Right, so it's essentially it's plus 1. Technically it's minus a -1, but because minus a negative is plus a positive, then you're doing y minus 5 equals 2 times x plus 1. So that would be your point slope form. Okay? Okay, last one. Kind of going back to the horizontal and vertical lines for this one. We're skipping example 4 in the book, so this is example 5 in the book, but our 4th example. Let's say you have this set up, and I'm just going to draw a graph, but you guys can put it on your own if you want, but it's just for a picture. Let's say we have this line here, and we have this line here. I will after we're done with this. It's just glaring so much right now. So if this point is 3, 4, okay, I want to know the equation of both of those lines, the equation of the blue line and the equation of the red line, okay? And sometimes these get a little skewed, but here's the deal. For a horizontal line, which one's horizontal? The blue one, okay? For a horizontal line, you're always going to have y equals some number, and that's going to be your equation. Okay? For a vertical line, it's always going to be x equals some number. Okay? Here's why it works that way. Wait till you're done writing so I get you seeing what I'm talking about up here. Okay, so here's the reason. In this horizontal line, this blue line, if I were to plot this point right here, that would be the point 0, 4, right? If I picked a point over here, that would be the point -5, 4. Well, what you notice about those 3 points is what's always staying the same. The 4, right? You have the same y value all the way through. So in a horizontal line, because your y value doesn't change, we would say the equation of this line is y always equals 4. Okay, so that's the equation of the blue line. For the red line, if you were to plot some of those points, this point here would be 3, 0. This one up here was 3, 4. Right? If I picked one down here, maybe it's 3, -3. Okay? What never changed on that red line? The x value, right? It's your 3. That never changed. So you have 3 here, you have 3 here, you have 3 here. So because your x never changes, we say x equals 3 for this line. Okay, so a vertical line will always be x equals the number. A horizontal line will always be y equals and whatever number your y value is. Does that make sense? Okay, so let's say I give you this graph. And this is 1, 2, 3, 4, 5, 6. And there's a line there. Can you tell me the equation of that line? Is it x equals or y equals? It's x because it's vertical, right? So it's x equals 6, right? We're at 6. So x equals 6 would be the equation of that line, okay? If I gave you 1, 2, 3, and I put a line there, now it's horizontal. What's the equation of that line? That would be y equals -3. Okay. The way I tell people to remember it is y equals, if you flip a y over, it kind of looks like an H, right? So y is the horizontal line. If you take vertical, that's basically making an X with 4 V's, or with 2 V's flipped upside down, you could say. So vertical is always x equals, horizontal is always y equals. Okay? You good?